With the advances in AI, the wave of autonomous driving is unstoppable. In the future, everyone can free their hands and gaze freely at the stars. But the road to this dream is full of challenges. To make it secure and reliable than human, the system requires testing a fleet of 100 cars driving non-stop for 225 years. Apollo is changing the game. Apollo is an open, complete, and secure platform that would help the partners swiftly build their own autonomous driving system. At the end of 2017, you can achieve Apollo's open driving capability for simple urban streets. By 2020, you will have the autonomous capability for highways and common urban streets. Apollo is bringing together numerous OEMs, Tier 1 suppliers, internet providers, government agencies, universities, research institutes, travel services, startups, and individual developers. The more partners, the more we can create and accomplish. In 1961, the Apollo lunar program was launched. And after 11 years, there are 20,000 companies, 200 universities, 80 research institutions, and 400,000 people who ushered into space age. Today, a new era of autonomous driving has already arrived. Apollo, it will transform China into the world's automotive powerhouse in 3 to 5 years. Apollo is the glorious beginning, an engine that will accelerate innovation, a sustainable and mutually beneficial platform, an open ecosystem built for collaborations. Apollo, let's work together to create a new era for the automotive industry.
Good afternoon and good evening. My name is Zhang Yaqin. I'm the president of Baidu. Very happy to see so many people. I'd like to begin by thanking all of you for coming to today's event. This is actually, I think, the first time we have this event outside of China. As you've seen from the video, autonomous driving is hot. The whole automobile industry is going through a profound transformation. And we see a lot of innovations happening in the last few years, and of course more come in the decade. And all these technologies, innovation, are creating new opportunities. According to McKinsey, this represents an overall opportunity of $1.5 trillion in the next 10 to 12 years. Obviously, the automakers and the Tier 1 suppliers will continue to play important roles in the future. But also we see new players coming into the picture. We see ride-hailing companies, the Lyfts, Ubers, and DiDis, and Zipcars. We see even logistic companies, the Federal Express, DHLs, running and automate their fleets with new technologies. We see, obviously, new companies making electric cars. And also, we see tech giants, tech companies like Baidu are beginning to invest very heavily on this. We also see two different approaches to different camps. One that is closed. You build everything by yourself, the software, and the hardware, and services, the cars. And the one that is open and making sure it's available for everybody. And we choose to take the open approach. And actually, we've been working on this for quite a number of years. And if you look at autonomous driving, it actually is accumulation of many different technologies. Computer vision, the sensor technology, big data, machine learning, high-definition mapping. So we've been working on all those technologies for probably over a decade. And last 3 years, we build different teams, level 3, level 4, and a focus on autonomous driving. And actually, put a road test, work with partners. But, we just like everybody else, work on silos. 6 months ago, it's April this year, we decided to make our system open, accessible. You saw the video, we call it Apollo. And because we believe autonomous driving presents similar challenges and promise as the historical lunar landing. To summarize, again, Apollo is an open, complete, and a secure software platform designed to enable all partners to develop their own autonomous driving solutions with reference vehicles and the systems. And the modular solution allows anyone to use as much as or as little as the existing technology and platform, the source code, as you need. So far, in 6 months, we have released 2 versions. The first version was released about 3 months ago, and with a lot of updates. The latest version, we obviously, our colleagues will talk more. We release things like obstacle detection or planning, deep learning technologies, all those core technologies. But also, we announced the openness of a lot of data. We share our algorithms. We also share a lot of valuable data we have accumulated for many years. So Apollo developers and users will now have access to a high-definition mapping produced by Baidu, as well as the world's only autonomous driving simulation engine. You will hear more, and this is really unique and can accelerate all the testing and the deployment of autonomous driving. So this includes a lot of actual autonomous driving data, traffic lights, road signs, and landmarks, and so on. One question actually I asked many times by media or by partners or by friends, why we are doing this, why we open our code, our platform, and our data. The reasons are threefold. First, we believe an open approach is the right path to creating the highest quality autonomous driving system. As our industry has shown, that open platform always outperform their close counterparts with a greater volume of contributions and innovation from partners. Second, actually, for most people, most partners, developers, open system actually give you more control over the data and the user experience, which actually is not possible by a closed system because they're not accessible. Third, Apollo creates and accelerates the pace of innovation because people no longer to reinvent the wheels, re-implement the things that have been developed. So we make sure we put 90% of the foundation technology code there, and our partners can innovate, differentiate on the 10% or actually more. I've been really enthused and encouraged by the development and the support of Apollo in the last 6 months. Last week, we announced a partnership with China's top auto brand, Jinlong, which is one of the 70 Apollo partners. So they are launching Apollo-powered autonomous bus for designated areas next year. A week before that, we announced another partnership with Beijing Automotive, which is one of the largest car companies in China, to mass produce level 3 autonomous cars by 2019 and level 4 cars by 2021. And also, Apollo is not limited just to transportation, the cars or buses. One of our partners in China actually built a automated street sweeping machine to clean public spaces like parks. Apollo is by Baidu, but not of Baidu, and definitely not for Baidu only. The auto industry is so large that we believe there's room for everyone to innovate and to succeed. Our mission is to democratize driving, not monopolize it. Many of you here today, the developers and partners, engineers, I encourage all of you to check out Apollo code at GitHub, which, by the way, is the #1 trend in GitHub C++ category. So I hope you check that out if you haven't already done so. Let's work together to advance the future of autonomous driving. With that, let me hand the mic to Wang Jingyao. He's the head of our R&D team here, head of actual Apollo R&D, which is based actually in Silicon Valley. This particular campus is building. He has about 100 engineers and we're working on this. So let's welcome Jingyao. Thank you.
Thanks, Yaqin, for the great sharing, and good evening, everyone. I'm Jing Ao. I'm a senior director of Baidu and in charge of Apollo platform development. I'm really happy tonight we have a chance. I will give you more details of Apollo platform. And it's about what is included, and what we have done, what we will do, and also how partners and developers like you use Apollo, the open source and the open platform, have a jump start in autonomous driving. When we design Apollo, we have 4 principles in our mind. Each of them is very important. That's the guiding of our design. The first one is open capability. And at Baidu, we believe in the openness. So we contribute our source code as an open source. We contribute our service to open service. And also we include the training data to help further development. Unlike other companies exploring the autonomous driving, and we think openness and open will make the best use of autonomous driving technology and the most accelerated. The second is shared resources. When we're talking about autonomous driving, we're not only talking about the source code, we're also talking about the data. The labeling data will make the algorithm, make the software evolve much faster, make much faster iteration. So by talking about the shared resources, we will open up our data and in several layers. So without any constraint, you can go to our website and get our labeling data for camera-based, for point cloud-based, for driving scenario-based, for free. And you can also get more data if you contribute more. So there is a very important principle. You contribute more, you get more. The third principle is accelerating the innovation pace for all of us. Within putting more and more data, and we will build better and better software. With better software to be open sourced, it will be put on more cars and put more on road and have more driving scenario and also more corner case. And in terms with all this data, we'll have better software and a better algorithm. So by doing all this together, we will accelerate the innovation collaboratively for every one of us. And the last but not least principle is sustained win-win situation. So Apollo is all about collaborating, cooperating. It's not about vicious competing. So Baidu will focus more on the software, will focus more on the high-valued service, which is included the high-definition map, included the simulation, and contribute this capability and the technology to make the whole industry innovate in a much faster pace. And in terms, together, we will make autonomous driving better and faster. So that's the 4 principles originally when we designed the Apollo. So bear this in mind, I will jump into the Apollo framework. Basically, Apollo framework is a 4 layers framework. From the very bottom, if we want an autonomous driving car, we need a vehicle. So it's referring the vehicle platform. And on top of that, we will refer to hardware platform. The hardware platform will include in the computing unit, which is the brain of autonomous driving platform, and also include all kind of LiDARs. So about camera, radar, and LiDAR, and the HMI device as a sensor. And the most right side, we will also include a black box, which is keep the security in a high level to keep the safety and the security for autonomous driving. And on top of the hardware platform, it's come to our open software platform. So built on the middlewares and the runtime framework is for all the software and algorithms for autonomous driving. Localization, perception, decision, planning, control, and the HMI, human-machine interface, all of them land together will become our open software platform. We will have more details of what each component included in the later session. And on the most top part is the cloud service. Cloud service provide a very important part for the autonomous driving platform. That some part very familiar with high-definition map about the simulation, and some part like data platform, like a security, online security, like the online over-the-air update, like the HMI back cloud interface, we call it dual OS, all come together will become the top layer. So Apollo platform is 4 layers complete system, include vehicle, hardware, software, and the cloud service. And by combining them together, we will achieve this Apollo roadmap. So we announced Apollo in April, and the very first release is in July in Beijing. It's for the closed venue waypoint driving. And in September, just last month, we released the fixed line driving with adding perception, decision, and the prediction capabilities. And by the end of this year, we will have another release for autonomous driving in simple urban road condition. And gradually, we'll keep iteration, we'll keep innovation, and toward the 2020, we'll perform the citywide highway and the urban road autonomous driving. After we announced Apollo, we get overwhelmed response from the industry. Currently, we have 70 global partners that include domestic and global OEMs, include tier 1 suppliers like Bosch and Continental, include the key component providers like Automstaff, and include the universities, include the startups, include the transportation service company, and also include the governments. So that is the whole list of our current partners. I know this is small, and we have much bigger partner logo back when you're in the reception area. So that is with all the partners. In July, we released Apollo 1.0. talking about the partner, and what about the open source? What about the source code we release? So we released the open source in July 5th, and in the second day, we ranked the top of GitHub C++ trending. And for the whole July, we ranked #1 in GitHub C++ trending. And for the less than 3 months, over 6,000 developers has started Apollo Auto in GitHub. 1,300 developers and partners has forking our code to use their product. And over 100 companies through our website applied for the open data provided by Apollo. We are not only stop there with open source in GitHub, and we keep adding new features and keeping adding new hardwares and software support. So we accelerate the innovation by faster iteration. And if you check the GitHub, you will see every week there are tens, even hundreds check-ins for the GitHub to add new features and increase the capability of Apollo. Developer is a very important part for Apollo system. Those are the Apollo Meetup in China. We open for developer, and the people are overwhelmed response, and with people standing for the whole session. And we know when talking about autonomous driving, Silicon Valley is a very important place. And Silicon Valley's developers, like you, is a very important part of the whole developer community. So today, this is our ever first Apollo Meetup for developers in Silicon Valley. And we are really happy to have this chance. And I think this is the very first, but won't be the last. We will continue to have Apollo Meetups for all the developers here. And it's important for us to work together to move autonomous driving technology faster. As I said, Apollo will announce in Beijing in July, but Apollo is global. Silicon Valley is very important. United States is very important. We also has Apollo Singapore to facilitate our Apollo globalization. Apollo is empower all the partners. Make the partner success is our goal. So it's include industry partners, it's include academia partners, it's include government partners as well. So next, I want to show you a small videos to see how partners can use Apollo open source code and Apollo reference hardware to get a jump start in their autonomous driving. And Keynote is the second largest bus manufacturer in China. They produce all kinds of bus, and one important part is electrical bus. It's 25 feet electrical bus, and Keynote uses Apollo's reference hardware and Apollo's open source code to make electrical autonomous bus. And with our reference, you can see it's our sedan cars. The Keynote, by using our document, by using our code, and they make this autonomous bus running in a week. So next, please see the video.
大家好，我叫柯志达，是金融客车工程研究院工程师。金融客车与百度经过前期的技术攻关与对接，从今天开始，我们将在金融微循环公交车上装载无人驾驶系统。目前，智能驾驶技术快速发展，大家可能看到很多小型的乘用车都装载了无人驾驶系统。今天，我们将开启一个新的征程。接下来，我们将在这辆车完成了百度阿波罗 1.0 系统以及设备的实车装载。
我们将进行联调测试。
这辆改装完成的公交车，接下来将进行场地测试。
我们现在开始测试，那个方向盘已经开始动了。
接下来我们开始实际的行机测试。车辆已经完全进入了自动驾驶的模式。前方有一个拐弯，我们来看一下效果怎么样。准确的完成了拐弯动作。定位的进度很高，我们的目标就是将乘客接送到我们指定的终点。这个门很窄，我们来看一下这个定位的精度怎么样。进来了，车辆即将到达终点，停下来了。这款搭载了阿波罗1.0系统的金融纯电动公交车成功完成了测试。很快，这辆金融微循环公交车将在我们内部进行实际应用测试。金融也将与阿波罗开放平台进行更深入的合作，快速推动中国商用客车无人驾驶的步伐。
Thank you. So, you can see, Keynote, they use our Apollo code and run their electrical bus. And all they did, the tools, the calibration, the debugging, even the HMI, the UIs, you can get today from our GitHub source code. And you will get all what they get in our GitHub. So we also want to see more and more partners can start and get familiar with Apollo code and get familiar with Apollo open system to make more and more use of autonomous driving technology. And thank you. Next, I would like to introduce our architect, Calvin, to talk more about the details. Remember, each blocks of perception and planning into technology details.
Thanks, Ying, for the introduction. Good evening, everyone. Welcome to our event. My name is Calvin, and I'm the senior software architect for Apollo. So let's refresh our memories by looking at the Apollo roadmap one more time. So we announced the Apollo 1.0 at Baidu Create AI conference back in July. And then 2.5 months later, we announced the Apollo 1.5 on September 20th. But for us, this is only a beginning, and as the video just says, that we just started our journey, and I believe all of us, all the team here will be dedicated to the Apollo project. We're gonna, keep working on this path. The yellow boxes here that you can see from the Apollo framework is are included in Apollo 1.0, the light blue boxes, I'm sorry. In Apollo 1.0, we demonstrated the ability of localization and vehicle control. The yellow boxes are included in Apollo 1.5, where we demonstrated the ability to autonomous driving on the fixed route in both the day and night times. So in order to do that, we also introduced the new hardware like LiDAR, etc., to be able to achieve this goal. So between the July and September, in these 2.5 months, we added about 65,000 lines of code. And we're going to continue our effort and by making more contributions together with all the developers here. And so I do encourage you to check out our code repositories on GitHub and make your contributions and let us know your feedback. In Apollo 1.5, we have five core capabilities: the obstacle perception, the planning, the cloud-based HD map, the cloud-based simulation engine, as well as the end-to-end deep learning. As always, the Apollo 1.5 will have the very detailed documentation and very comprehensive debugging tools for the developers to debug their system, to verify their system on board. So next, let me just dive a little bit into some of the important modules in Apollo 1.5. The first important module is the obstacle perception. Without an accurate perception system, the car will not be able to move from one point to another in a safe way. But different companies may have different strategies for doing the perception. Some companies may use the vision-based strategy. Some companies will adopt the radar, but for us, we're using the Valentine 64 LiDAR to do the perception. So when the point cloud data comes in, we clean the data, and thanks to the RI services provided by our HD map, we can significantly reduce the number of points that we're not interested, and we're only focusing on the areas that we're going to spend more time computing by running algorithm on it. And then our perception used the deep learning technologies to segment the point cloud data and to detect the obstacles. Our system is running on NVIDIA GPU, and it's running on 10 Hertz frequency. Next is the prediction. Prediction is an extension of a perception in both the temporal and spatial dimensions. We're also using deep neural network technologies to precisely predict what those obstacles will move in the next short time frame. We have multiple predictors in our prediction module to be able to handle different categories of the obstacles: vehicles, pedestrians, cyclists, etc. And all of these algorithms can be easily implemented and plugged into our system. So if you want to, for example, if you want to make your own predictors, you can easily implement it. You can plug that into our system, and the algorithm can be easily activated and scheduled with a very simple config file update. The next very important module is the planning. Planning enables the car to drive from point A to point B safely, smoothly, without any traffic rule violation, without collision with all the obstacles along the way. Our planning takes the inputs from multiple dimensional spaces, we take the inputs from routing, from prediction, perception, from localization, and then we reconstruct the world in the eyes of the ego vehicle. And then we use multiple optimizers with the dynamic and quadratic programming to iteratively optimize the trajectories that we output. So we have to guarantee that we always output the most highest quality trajectory for them. So end-to-end learning is sort of like an exploratory and experimental effort by our Apollo. So in order to work with different control and canvas systems, we reversed dynamic models by outputting the curvature on the lateral dimension and the velocity and acceleration in the longitudinal dimensions. So if we talk about the technologies, we use both the very classic convolutional neural network as well as the very innovative combination of both the convolution and the recurrent neural network. So up to now, I think a lot of people are really excited about what Apollo 1.5 has. And you may be curious about how the Apollo 1.5 may run on the real vehicles. Fortunately, we have one of our partners in Beijing that deployed Apollo 1.5 on one of their vehicles. So I'm going to show you a short video on how they deploy the system and how they test Apollo 1.5 in their vehicle. So you can see how the Apollo 1.5 can run on the road.
我们是一群来自清华、微软研究院、中国科技大学的年轻人，为了同一个目标走到一起。我们希望给汽车装上大脑，让它像人一样拥有智慧。 这样我们以后开车就可以解放双手，仰望星空。我是某门塔的工程师王振阳。今天某门塔将与百度合作，共同组装一辆具有阿波罗 1.5 开放能力的无人车。我们在车上集成了阿波罗 1.5 的开放技术，主要包括了固定车道的跟车、治安物识别以及高精度地图。阿波罗 1.5 开放的技术非常稳定，在正常能见度条件下表现得非常突出，特别是在跟车和治安物识别方面表现很棒。为了探索阿波罗 1.5 无人车的优异性能，我们又增加了测试的难度。在能见度很低的夜晚，这款搭载阿波罗 1.5 技术的无人车对于治安物识别的精度也让我们惊喜。我们发现阿波罗 1.5 开放技术检测能力很棒，我们确信百度加上某门塔可以碰撞出非常激烈的火花。
我经常被问到的一个问题就是说，阿波罗计划对于你们来说会产生一个什么样的影响？我们发现回答这个问题最好的方式就是加入到阿波罗计划里面去。现在我们跟阿波罗在激光雷达的环境感知以及障碍物检测方面开展了合作。未来我们希望进一步加强和阿波罗在深度和广度方面的合作，共同加速无人驾驶技术在中国的落地。
So this is very impressive because honestly, Momenta set up, deploy the system, and also finish all the road tests just within 3 days. So next, I'm going to talk a little bit about the two important software services in Apollo 1.5. So the first thing is definitely the Apollo HD map. The Apollo HD map is the foundation for autonomous driving for Apollo. We know that HD map is very critical in different aspects of autonomous driving. For example, localization. You need to know exactly where you are. You have to locate yourself on the map. Perception, as I mentioned, we have this RI service packed in Apollo HD map services as well to allow you to reduce the computation overhead. Planning, we provide the HD map for planning to be able to plan a very safe, high quality, and a smooth trajectory. And of course, the cloud-based simulation engine. So our simulation engine has the embedded HD map to allow the replay of all kinds of traffic scenarios. So let's look at some of the examples of how the HD map can help with the autonomous driving. The first one is the traffic light detection. So our HD map will precisely label the traffic light within each image frame so that the camera and our algorithm can only focus on that small areas to reduce the detection error. Another good example of how the HD map can help with the autonomous driving is the junction. So we know that the planning needs to plan the trajectory to allow the car to drive on the lane. But what about a junction? Because the junction doesn't have the lanes. So our HD map has constructed a lot of interconnected virtual lanes within the junction to help the planner to be able to plan the trajectories. So our HD map has a lot of traffic elements, the roads, even it comes to lanes, like the lane boundaries, the lane marks, the length, the width of the lanes, the center line, speed limit, and also has elements like the crosswalk, the stop line, clear zone, road surface tax, etc. And also we have some sort of like traffic elements describing the relationship between multiple traffic elements. For example, the overlap, which can describe the interaction of crosswalk and the lanes, or the stop line and the traffic light, etc. Our HD map is super accurate. It comes to centimeter level precision. Producing our HD map is very efficient. Over 90% of the production is done automatically using AI technology with over 95% accuracy. This is pretty impressive. So our HD map will cover pretty much all the freeways and the major urban roads by the year 2020 in China. So some of you may have some concerns, like if you don't have the access to some of the maps outside of China, and so now I think your concern can be relieved because our HD map data is in the industrial standard OpenDrive data format. So that means if you don't have the access to our China data, but as long as you have some data, which is some map data, which is in OpenDrive format, you can easily use our map engine to load your data and query your map elements. So before I come to the simulation engine, we can take a look at a small video.
Baidu Apollo project has open sourced its self-driving system in order to enable the business partners to establish their own complete system in a short period of time. As one of the most important capabilities of Baidu's Project Apollo, the simulation technique plays a significant role during the R&D process of self-driving cars. Firstly, the simulation system consists of traffic scenarios very similar to the real world, which means most of the potential problems which may happen during the road test can be detected and solved in advance, therefore improving the efficiency and safety of the self-driving system. Secondly, the large-scale simulation system has the capability to optimize the self-driving algorithm with just a little manual intervention, which makes the development cycle much faster and more intelligent. Based on the large-scale cloud computing clusters, the simulation platform provides plenty of traffic scenes with built-in HD map and professional metrics for automatic grading, which enables the developers to test millions of virtual miles in a single day. The virtual road test is able to be consistent with the reality, including the runtime environment, the map data and the traffic scenes, thus accelerating the development of self-driving technology. The simulation platform is not only available for Apollo interface, but also compatible with non-Apollo interface frameworks. The users can run verification of the algorithm by plugin of one or more modules, and of the tests of image level. The flexibility and compatibility with various interfaces will be helpful for developers to master the professional self-driving simulation software. In the future, the simulation platform will provide more realistic traffic scenes, expand the coverage area of the built-in HD map in highways and urban roads, and open the grading metric interface to support customization, and offer the developers full service in the self-driving field. Meanwhile, Baidu will open up more techniques and resources to make the self-driving cars R&D more accessible and empower the partners to bring the future of self-driving technology closer.
Yes, so this is our very advanced cloud-based simulation engine. So simulation is the accelerator for autonomous driving technology development. When design or develop a self-driving technology, I think a lot of developers or small startup teams are facing some of the pain points. For example, if you for one technology to be adopted and to mass production, you need to pass at least like 10 billion kilometers of road test. That means you need to have a fleet of 100 vehicles running 7x24 for continuous 25 years, which means it's almost impossible for individual developers or small teams to finish that. And also a lot of developers or small teams are concerned about they don't have enough data to train their models, or they don't have enough traffic scenarios, especially a lot of corner cases to test their system. So our cloud-based simulation engine tries to address your concern. Our simulation engine will have the embedded HD map to replay all kinds of road scenarios. We have huge amount of traffic scenarios to test your system. Our simulation engine is a cloud-based service, meaning it's running super fast. And we do provide over 200 professional performance metrics to measure how good your system is. If you have any violation of the traffic rules, you have a collision with obstacles, how comfortable your driving experience is, etc. So together, all these things will be packed in the simulation engine in Apollo 1.5. All kinds of autonomous driving scenarios, your functionality verification, our performance matrix, and also you can visualize how your system can be run in our simulation platform. So by the end of this year, we're gonna open more capabilities in simulation engine. For example, we're gonna have more complex traffic scenarios for you to test. We're gonna have more professional performance matrix to score your system, and also our cloud services will be more powerful to test your services. So we promise that by the end of 2018, your vehicle is able to run over 1 million kilometers within a day. So let's take a look at of the highlights of Apollo 1.5. So we have the perception, we have the planning, we have the HD map, and the simulation engine as a cloud services. So Apollo 1.5 is the most comprehensive Apollo system we have ever released up to now. We use very advanced deep learning technologies, use very iterative optimizers for different kind of optimization. Our system is very scalable, meaning you can easily integrate your contribution. And our system is also very developer-friendly. For example, if you want to do the LiDAR calibration, you can simply collect the LiDAR data and submit that into our cloud service. And then soon you can get the calibrated data and deploy that in your car. Our Apollo 1.5 code is available on GitHub already. I do encourage all of you to check out our code repositories on GitHub and please give us the feedback. Our Apollo 1.5 is actually under the license of Apache 2.0. So your contributions is very welcome. We want to hear your feedback so that we can make sure that your expectation is in line with the things that we are working on. And all our engineering teams are here, so please let us know your feedback, and we do believe that your success is our success. Thank you. So next, one of our speakers come from one of our partners, Wolfgang from Autonomous Stuff.
Thank you very much, Calvin. This is it's actually an honor that we have been asked to speak on our experiences at Autonomous Stuff with the Apollo platform, and I've seen many faces in the audience here that I'm already familiar with, since Baidu actually is, even so this has only come out since July, but Baidu has been working this for a long time. They were actually one of our first customers for our platforms back many, many moons ago. So for the people that don't know us, don't know me, I'm Wolfgang Juchmann, the Vice President of Sales and Business Development at Autonomous Stuff. And Autonomous Stuff is a company that provides all the stuff to make autonomous cars. We don't make autonomous cars ourselves. We help other companies to make self-driving cars, for example, Baidu, but many of you in the audience know me. And what that means is we provide automotive-grade perception sensors that you can use, which might be LiDAR, radar, cameras, ECUs, GPS IMU, data storage, essentially any stuff that you need to make a self-driving car. We also help you to integrate those sensors onto the cars, and that might be your own cars or that might be our cars, and we offer a full by-wire platform that you get an interface to access. You have full access to steering, acceleration, braking, and shifting through the gears. So you might have seen at the beginning those two Lincoln MKZs in the back and in the videos here. So those were provided by Autonomous Stuff. We provide that hardware, and combining that with the technology from Baidu is this game changer. So we are together redefining the future of mobility, using Baidu's resources and finances, combining that with Autonomous Stuff's hardware and technology and know-how, and then pairing that with Apollo as an open platform to bring this technology forward and make Autonomous Stuff happening. Our goals are actually very well aligned with the goals of Baidu. And I will show you 3 bullet points out of our mission statement that we didn't know. You will see what this comes to. So our goals are to enable the future of transportation, to significantly reduce the development time, and listen to this one, to rocket this industry forward. So you can imagine when we heard that Baidu is going to call the new platform Apollo, and we have rocket in our statement, we were very delighted because you couldn't have a better match to get this going. So we believe this is the ultimate combination. This changes everything. And I want to show you a little video of one of our engineers. This is from the opening part in July, on July 5th in Beijing, where one of our engineers, Josh Whitley, actually had the chance to go to China, and he helped to install the Apollo 1.0 onto one of our MKZs. And within 3 days, they actually had the car self-driving. And thanks for the video.
My name is Josh Whitley. I'm the lead software engineer with Autonomous Stuff. Been in information technology for most of my life. I started my first IT job when I was 15. I've been working at Autonomous Stuff for 2.5 years. So I was very excited to get the opportunity to come to China. Baidu making an open source project that people can contribute to and add meaning to is very useful. We'll go outside and verify that the hardware is working. Yep. Yeah, it was a bit hard braking. It's great to have a wide open space like this for testing. We're going to come up to the end and the vehicle should make a full stop.
In order to enable the future of transportation, you have to put together an ecosystem of partners.
The test is going very well. With the help of the software team from Apollo, everything installed and worked the way it was supposed to. With the support of the Apollo team, we can finish it in 3 days.
I'm very proud to have developed this relationship with Baidu, and trust me, this is only the beginning.
I'm pretty excited. I mean, back in July, Apollo had about 50 partners. Now it's almost 75, which is almost a 50% increase. But as Yachi said earlier, it's 6,000 people have downloaded this code. I mean, that speaks for itself how important this is to this community to work with Apollo to get working on that. It's actually a game-changing. Baidu opened up Apollo as an open source platform. Autonomous Stuff brings all the technologies together, the hardware to make this able. We actually went one step further. We created the Apollo Starter Kit that you can find on our website, which includes all the different hardware elements that can be used to make Apollo run. So if you wonder where you get technology from to use Apollo, you can get that from us. And with the introduction of Apollo 1.5, we have also added 2 more components. One is the GPU that Calvin spoke about, and of course the Velodyne LiDAR HDL64. And our engineer, Jeff Ridley, that we just saw, when he saw that Apollo 1.5 was available, of course he had to download it, and he said he tried it out. Within hours, he was upgraded from 1.0 to 1.5. He was very happy, very satisfied. And he said there's even an auto start button on there that makes it so easy. So the conversion from 1.0 to 1.5, you don't have to worry about. It's very, very easy and straightforward. And I already mentioned the new hardware. Calvin went into a little bit more detail, but the 2 main points in terms of actual physical hardware that's included now and supported is the HDL64, which is Velodyne's high-resolution LiDAR scanner, very good for object detection and generating maps, and our Spectra ECU that has an NVIDIA GPU 1080 in it for the end-to-end artificial intelligence learning. The capabilities that you get with that, in a nutshell, before it was mainly path planning plus waypoint following, so you used a high-end GPS system for Novatel to follow a pre-recorded path. Now you can actually combine that with obstacle detection in real time. You can generate a high-definition map and do cloud-based calibration services, as Calvin already outlined. And on the GPU side, obviously, you need a GPU processor to enable the artificial intelligence algorithms and tool developments, and that's really what's now available with Apollo 1.5. So this is a breakthrough. This is just the beginning, as our CEO just said, and the future is here. So with all of you in the room involved in autonomy in some way, let's tackle the future, and thanks a lot to Apollo and the Baidu team. I will hand the microphone back to Jingao, and he is going to have some more remarks. Thank you.
Thanks, Wolfgang, for the sharing, and also thanks for the video. So at the beginning, for the 48 hours, they put on Apollo 1.0, and it's still heartbreak, right? You can hear the sound, and just 3 days later, and all works. And even best part, right? Wolfgang just mentioned, you work with 1.0, and upgrade to 1.5, add much more capabilities like obstacle detection. It's easy. Right? So, and keep upgrading, and we will keep this pace and moving the innovation of autonomous driving faster together. Next, I would like to share another important part besides GitHub open source. It's our ecosystem. When we're talking Apollo, it's about all the partners and all other developers. And we did go out to ask questions. So we asked, what else do you want besides the open source code, besides the GitHub, right? The number one question is money. So we list number one, so it's about the capital, about the fund. And next they mentioned about we need more data. We want to training the deep learning algorithms we have. There are deep neural network, there are convolution network, there are GAN network. More data is better. And then next, they mentioned about softwares. Can we easily plug in our software? Can we use our existing software, using our existing operating system on basis of Apollo? And they're talking about hardwares. Where can I buy hardware? If there are any button we can buy, then all them together, more easily accessible. And then next is we need a talent. We need developers. We want more education on Apollo side, on the autonomous driving, on this deep learning, on this high definition map, on this perception. So education is a very important part. And the next part is they need testing, and they need to put on this road. So all around together, right? So we think about how, as Apollo, we can support our partners and the developers better. So capitals, data, software, hardware, and more education, and more testing. So talking about the first one, capital, we are really happy to announce Apollo Fund, $1.5 billion US in the next 3 years. We will use this money to invest 100 projects with Apollo. And it's global. It's not only in China, it's also included here in Silicon Valley. And 1.5 billion we will spend this way. We will basically spend for 4 major areas, which we think is very, very important for Apollo ecosystem. The very first one is the hardware part. So that includes LiDAR, that includes camera, that includes the computing chipset. So that is for the hardware side. The second part is the production. So that includes OEM. That includes the transportation as a service. This includes what we see in the video, that the Keynote bus, right? They make a self-driving bus. And the third part is for the data part. So for the cloud service part, It's include the high definition map. It's include the high definition localization. It's include the security service, which is the OTA service we mentioned before. And of course, it's also included the simulation part. So that is third part. And the fourth part, of course, is our development community. No matter you work on the algorithm, you work on the operating system, you work on the function safety, which is a very important part for automobile industry, and it's for self-driving. So we want you. We want to hear from you. So 1.5 billion Apollo fund invests next 3 years in these 4 major areas: hardware, product, cloud data service, and the development community. After money is talking about the data. One very important part of nowadays the autonomous driving is we use a lot of deep neural network, artificial intelligence, and it's needed. When we're talking about the developers, what do you think? They think it is more data is better. How many data is enough? The more, the better. But they want to see the high quality data, the more, the better. And now it's come to Apollo's crowdsourcing training data labeling service. So we open up our cloud sourcing labeling data service to all the Apollo partners. So what is our strength? So we have more than 50 labeling service team, and among this team, more than 5,000 well-trained operators and can labeling the data for all the Apollo partners and the developers. And indeed, they, as Baidu before, we use their service. So we developed special tools for them to make them more efficient, more effective in labeling data. And so combined with the experienced team and combined with the easy, efficient tools, we can produce quality data in high volume in very short time frame. Let me give one example for you. Plus AI is a startup, and they work on the deep learning camera-based perception, and they want to define the lines. They want to detect the obstacles. They want to know where's the drivable areas. So they starting the pilot customer using Apollo crowdsourcing labeling service. So in a week, they can get over 30,000 lines labeling, 15,000 areas labeling, and more than 150,000 frames of obstacle detection. And not only about this huge amount of data they get, the quality is very high. Based on their estimation, the accuracy of Apollo's crowdsourcing labeling is over 99% accuracy. So by doing this, you don't need to build your own labeling team. You don't need to build your own tools. You can really leverage the service, crowd service Apollo provide to speed up your own innovation. That's the second part for the data. And after data, it's come to the hardware and the software. So the list over there is our Apollo current 1.5 hardware reference list. You require that to run our hardware 1.5. And all this information about the specification is listed very clearly in our website, also in the GitHub README document. And previous, you already hear Wolfgang said, in Autonomous Stuff website, you even can click a button to get all of them. And then next is more about the partner on software and education. And by doing that, we collaborate closely with open source community. So I'm very pleased to introduce Nat from Open Robotics, CTO from Open Robotics, talking about ROS and Apollo. Let's welcome Nat.
Hi, good evening. It's a pleasure to be here, especially with a captive audience about open source, especially open source robotics. I'm here to talk about what we do at Open Robotics and how that dovetails in with Apollo. So at Open Robotics, we develop primarily two software applications, the first one being ROS, which stands for the Robot Operating System, and the second one being Gazebo, which doesn't really stand for anything. ROS is basically the robot SDK that a lot of people use to control and interface their software with hardware. Gazebo, on the other hand, is a high-fidelity 3D robot simulator. Its primary use is for testing and designing robot hardware and software in simulation. So why am I here and why am I talking about ROS when this is an Apollo meetup? So under the hood, Apollo uses ROS to handle a lot of the nitty-gritty details of getting a robot working, such as passing data around and establishing a robust and reliable network. This is the bread and butter of ROS, essentially. And we are now going to be working with Apollo closely to help define the features and the roadmap for ROS and ROS 2, the next version of ROS that's coming out later this year in December. And this is actually an exciting opportunity for us because as developers of a library, it's a rare opportunity to interact directly with developers that have a particular end use case in mind, which can then in turn feed features and requirements back to us. In the same way that you all can use Apollo and feed features and fix bugs on Apollo itself. We also share this open source mentality. The name Open Robotics, obviously open is used for a very particular reason. All our software is free. We are not driven by profit. We do actually pay our employees, which is good, but we can talk about that later. We have licensed all of our software under BSD and Apache 2 in a similar way that Apollo has. And the goal is primarily to promote, distribute, and advance the state of the art when it comes to robotic technologies. And this actually proves to be extremely valuable to everyone involved. As pointed out in previous presentations, the more people you have working on a code base, the more features get developed, the more bugs get fixed, and it's actually been shown that open source software is more secure, is more reliable than closed source. And you can probably think of the last time Windows crashed on you and you filed a bug for that. So what is ROS? What is the Robot Operating System? So ROS is fairly old in a good way. It's roughly 10 years old. It started in 2007 with the first major release in 2010, so we're happily celebrating its 10th year. I don't know how software years work in terms of, say, dog years, but hopefully it'll last quite a bit longer. Over the years, we've collected quite a large community of developers and contributors to ROS. Unfortunately, it's relatively difficult for us to measure how many people use ROS. A lot of times, users come out of the woodworks through meetings like this, but we can look at anecdotal data, like how many people visit our wiki, which has numerous tutorials and educational materials. So ever since the first release until now, we've dramatically increased the number of people that are at least reading about ROS. This may not be an overwhelming number to sites like Amazon or Google, but for the niche internet space that is robot software development, this is pretty good and quite impressive. Of course, ROS is more than just is used in more spaces than just autonomous vehicles. It's been deployed on aerial vehicles, humanoid robots, mobile bases, mobile manipulators, and in particular, it's actually on the NASA Robonaut 2, which is currently on the space station. So we have ROS in space, which is pretty exciting. So going forward, we are actively working on ROS 2, as I previously mentioned. This coming December, we'll see the first major official release of ROS 2. This has been a work in progress over a number of years. We've incorporated the feedback and experience that we've gained over the past 10 years to improve the API, various features, stability, security, robustness, and so forth. The biggest change that users will see is take a departure from our own custom message passing system to a more industry standard version, which is called DDS. It's used widely in industry, in government, and by NASA and other institutions of that nature. So we feel this is a good opportunity for us to step away from maintaining that part of the code base and move on to other things. Additionally, we'll start looking at how ROS can be deployed into embedded systems, which has historically been a little bit of a pain point for us, and making it more flexible and easy to use real-time systems with ROS 2. Basically, you can devolve this all into the notion that ideally people spend less time working on how ROS works and spend more time on developing cool new features and capabilities and expanding the ecosystem of ROS. So I want to spend the last little bit of this presentation talking about the other project that we work on called Gazebo. You saw a little bit about simulation in some previous videos, and they touched upon a lot of reasons why simulation is important. Increasing productivity. Unless you can give a car to every single software developer, it's going to take you quite a while to have everyone iterate through their testing and development on your hardware platform unless you use simulation. Safety and data collection are all obvious use cases in simulation. And more recently, we've started to see simulation used in terms of design. So if you want to try out where a new sensor goes or experiment with the length of an arm on a robot, you can easily do that in simulation without having to spend a lot of time and money developing this and deploying it in the real world. So how does Gazebo differentiate from other simulators out there? We spent a number of years focused a lot on physics. So Gazebo is essentially a 3D dynamics engine. So everything that Gazebo does is taking into account of the kinematics and dynamics, so all the inertia, joint frictions, interactions between objects in the world, sensor simulations, and so forth. So it's meant to be a high-fidelity, best representation of the world possible. And of course, since we're open robotics, that we also develop ROS. If you use ROS, you can use Gazebo. If you use Gazebo, you can use ROS. They play well together. So in this video, it shows some of the use cases that Gazebo has been deployed in the past. So this includes industrial arms, mobile manipulators, various humanoid robots from the DARPA Robotics Challenge to soccer-playing robots, NASA R2, and even swarm vehicles where you have aerial vehicles with actual aerodynamics taking place, and underwater vehicles. This is a highly extensible general purpose simulator that can be extended essentially to your heart's content. Okay, we can move on to the next slide, please. And finally, I can't leave without actually showing a video of some type of autonomous vehicle. This is a little world that we put together fairly recently to demonstrate a Prius driving through a fictitious environment. So the key takeaway here is it may not look as nice as other simulators, but this entire powertrain of the Prius is being modeled. Everything from fuel efficiency down to tire friction, all the other objects in the world, and the sensors and the interactions that are taking place. So this is meant to be a platform that developers can use to mimic the real world, try out their algorithms and safety, and do it rather efficiently. Okay, we can skip the rest of this, please. So in summary, it's really an honor to be here. The philosophy that Open Robotics has with Apollo and Baidu are very well aligned. We both have this notion of developing open source software, building a community, leveraging internal knowledge and the experience that other people have to advance the state of the art. And that's what we've been doing for a number of years, and it's exciting to work with other people to help make this a reality, especially in the domain of autonomous vehicles.